I'm going to show you two ways to this question. First of all, yeah, you could just try some numbers out until you get to the one that kind of works. So let's say we've got 11 teams. Then there would be 33 players, and they're going to play each other. But obviously, the players in the same team are not going to play each other. So there would be 33. So each player would then play 30 games, basically. So it would be 33 times 30 for the number of games, but I've double counted because I've included A playing B and B playing A. So I can divide that by 2. So that's going to be 33 times 15, which is definitely going to be bigger than 250, so way too big. So let's go on the opposite end of the spectrum, 7 teams. Now there's going to be 7 times 3, 21 players. They're going to play against each other, but again, they're not going to play against their own team. So it's going to be 21 times 18. Double counted, so divided by 2. That's going to become 21 times 9, which is 189. So that one works. But is that the smallest number? Let's have a look at 8 teams, because it's not too far away from 250 when we consider how big that one was. That was like over 400. So 8 teams. We're going to get 24 players now. It's going to be 24 times 21 over 2, which is going to be 12 times 21. So that's going to be 210 plus 42, 252. So slightly too many because remember, it was less than no more than 250 games. So we'd have to have 252 games here. And that gives us our answer. It must be E. Now, I just want to show you how we could do this algebraically. It's more complicated, so actually, for the purposes of this competition, I don't know, quite like that approach. That's how I did it. But let's work more generally. Let's say we've got n teams. Then there's going to be 3n players. And they're going to play against 3n minus 3 other players, just like we've had over here. So there's going to be 3n times 3n minus 3 over 2. Don't forget the double counting term, games. Actually, I don't need to write games. I can just say that this has to be less than or equal to 250. Okay, really stepped it up here, but this would be how we'd deal with the question if we didn't get multiple choice, or if you wanted to do it without trial and error, if you wanted to generalize this problem. So I can actually factorize the 3 out of here, and I'm going to get 9n times n minus 1 is less than or equal to 500 by timesing through by 2. Let's see what happens when I do 9s into 500. It's not going to go, but what's the remainder? We're going to get 9s into 50, go 5, remainder 5. 9s into 50, go 5, remainder 5. So it's going to be 55 and 5 over 9. So n squared minus, actually, let's keep it factorized. N times n minus 1 is going to be less than or equal to 55 and 5 over 9. Now remember, this is a whole number over here, so n times n minus 1 is going to be less than or equal to 55. Again, we've basically kind of constructed a quadratic inequality, which you may have never learned how to solve. So in this case, I think it's okay to just put some numbers in. We could maybe let if n was equal to 11, we get 110, way too big. If n is equal to 7, then we're going to get 7 times 6, which is 42, that works. If n is equal to 8, then we get 8 times 7, which is 56. So close, but again, not enough. So that's another way of showing that n would be equal to 7. If you wanted to just like completely show this algebraically, then you could multiply this bracket out, n squared minus n, subtract the 55. Actually, yeah, I'll stick with the 55 rather than 55 and 5 over 9. Um, so n squared minus n minus 55 is going to be less than or equal to 0. And you'd actually have to solve this quadratic inequality. You could solve a quadratic equation, which in this case would not lead to nice integer solutions. It doesn't factorize. Would get n equals, I'll put this into my calculator, minus 6.93 or 7.93. So that shows us we're just off of 8. And then you could draw the graph. Okay, I'm going into more detail than is needed here. And we'd look at, so this is minus 6.93 and this is 7.93. And these are the range of values that I'm interested in because it's where it's less than 0. And so here we can clearly see that it's the largest value of n that's an integer is going to be n equals 7. And it would work for like 1, 2, 3, 4, 5, and 6 as well. Obviously, we discount the negatives. And the only reason I'm really talking about this is that, if you were generalizing the problem to like some number of games that wasn't 250, then you could use this approach to find the values for that number of games. Let's move away back from that. So two methods. Actually, the second method still pretty much involved a bit of trial and error. So you know what? I'm pretty happy with what I did right at the start. In any case, it's going to be 7 teams.